A clamp has been tightened on wooden planks being glued together until P is equal to 400 newtons. Determine in section AA the stresses at points A and D and the location of the neutral axis. Now, keep in mind that the neutral axis is where sigma is equal to 0. So, let's cut right here at A, and let's draw a free body diagram. So, right here we're going to have this. And this. Okay. So we have our P here, and they tell us what that is. It is 400 newtons. 400 newtons. And they also tell us that this distance is 50 millimeters. Okay? What else did they tell us? Well, let's see. We will need a force this way. An internal force, P. And we notice that P does not act at the centroid of the whole shape, which means that this is a case of eccentric axial loading. Which means we're going to use to find the internal stress, which then is going to be used to find the stresses at A and B. We're going to use P over A minus My over I, which is superposition. So let's see, what do we already have? Well, we know that P is going to be 400. So that's already something, right? This is my P. We can find A. For example, A is really going to be 10 times 4 plus 4 times 20 minus 4, which is 16. And so what is that going to be? Well, 10 times 4 is 400. 400. And 4 times 16 is 40 and another 24, so that's 64. So 464 would be the total. 464 millimeters squared. That's our area. So we can already do the first term, honestly, if we want to. And then y, we just need to measure based on which point we needed to know the stress at. So what do we really need right now? Well, we need to know the moment and the I. So for the moment, what are we going to do? We need to first find where the centroid of the cross section is. So let's see. We can divide these two shapes and say this is my one and this is my second shape. And we're going to say that my y, the position of the centroid, is going to be my area 40 times wherever its centroid is, which is at 20 minus 2, which is at 18, plus we're going to do 16 times 4, which is 64. That's the other area. And the location of its centroid, which is at 8. And we divide everything by 104, which is the sum of the two areas. So what is that going to be? 40 times 18 plus 64 times 8. All of it divided by 104, we get 11.85. 11.85 millimeters. So now we can say that at 11.85, so kind of like right here. Oh, I think it's where they drew it. This is my centroid. Right here. Okay. So let me write that. Y is equal to 11.85 millimeters. Now, why is that useful? Well, because now we can say that this whole thing is 20 hold on. This, we can say that the distance, this whole thing is 20. How do I draw this? This whole thing is 20 millimeters. And we know that this is 11.85. So we know that this P acts at a different, so we really want to know this distance, not the P. We want to know this whole distance, because that's about what this 400 acts on. And this is 50 plus, so that's our distance D, because that's going to give us our moment about the cut. Sorry, this is a moment. And so we can say that M, the sum of the moments about the cut, must be equal to 0. So we'll do a positive M and then a positive, because the 400 with the right-hand rules moves counterclockwise, so positive, times 400. And now that D becomes 50 plus 20 minus 11.85. And all of that must be equal to 0. So really we can say that our M is equal to minus 400 times 50 plus 20 minus 11.85, which is minus 23260. Minus 23260 Newton millimeters. Okay? And so we have our M now, the moment at the cut. And now what we do is we find our I. So our I is going to be, well, now that we know where the centroid is, it's going to be our first shape again. This is 1. This is 2. So 40, 1 over 12 times 10 times 4 to the third. I don't even need the parenthesis. Times 10 times 4 to the third. And we want to shift it where? Well, we know that this is going to be 2. And we want to get from 20, we want to subtract 11.85, and then we want to subtract 2. So 20 minus 11.85 minus 2. That's the distance squared, and the area is 40. And that's for the parallel axis theorem. So what is that going to be? 1 over 12 times 10 times 4 to the third plus 20 minus 11.85 minus 2 squared times 40. That's 1566. So 1566. And that's going to be millimeters to the fourth. And then the other part is going to be 1 over 12 times 4 times 16 to the third plus 11 point, no, how much do we want to shift it? Well, we're going to be at 8 and we want to get to 11.5. So 11.85, sorry, minus 8. Squared times 4 times 16. And what we get is 1 over 12 times 4 times 16 to the third plus 11.85. Oh, I pressed equal without. Continuing, plus 11.85 minus 8 squared times 64. And we get 2314. 2314 millimeters to the fourth. So the total I is going to be 1566 plus 2314, which is going to be 3,880 millimeters to the fourth. So now I have my I have my M. So I can say the sigma at A is going to be equal to what? 400 newtons divided by my area, which we calculated it as 464 millimeters squared, minus what? Well, we're going up, so we're going to be, are we going to be in tension or in compression? That's the question. And that's because, think about, where is the moment? This moment is negative. So that'll take care of that. So minus 23260 multiplied by wherever my A is. My A is how far from the neutral axis? It's 20 minus 11.85. So 20 minus 11.85. It's 8.15 away from the neutral axis. And then we want to divide by my I, which we said is 3880. And so if we do all of that, we get 400 divided by 464 minus the negative of 23260 times 8.15, all divided by 3880. What we get is 49.7, which is not what I'm supposed to get. And the reason for that is because it looks like we did something wrong with the areas. I said 464 because that's not a 40, that's a 4. So this would be 104, as it should be here, right? So I apologize for that mistake. So this is 104. And I hope that fixes the problem. 104 minus the negative 23260 times 8.15 divided by 3880, get 52.7. 52.7 megapascals. And we see that it's positive, so this is in tension. Now we do the same with the point D. So we know we're going to have still 400 over 104, just as the previous problem. We're going to have that same moment and that same area moment of inertia. But now we look at our distance from the centroidal axis, and that's going to be 11.85. And so let me do that. 11.85. We get 70. You get 74.8. 74.8 megapascals in compression. And I'll have to see if this is the correct answer. And I'll put it in the comments below because we might have done a mistake. And then I'll let you know what mistake that is. Or how about you find it and tell me in the comments. So now we're going to find the neutral axis. So the neutral axis is going to be when sigma is equal to 0. So we're going to do 0 is equal to 400 over 104 minus negative 23260 times y divided by 3880. So how do we solve for y? Well, we're going to add this to both sides. So we're going to have minus 23260 divided by 3880 equals to 400 over 104. And then this is my y. So my y is going to be 400 over 104 times 3880 over the negative of 23260. And so let's see, 400 divided by 104 times 3880 divided by minus 23260. We get that the neutral axis is at minus 0.641 millimeters. All right. I hope this was useful, and I will see you next time.